This is a conceptual problem. So in this problem, it says how many times larger or smaller would the pressure of a sample of gas in a container be if the volume of gas went from 4 to 8 liters? First of all, you need to understand that we've got the term pressure here, and we have volume, and we're actually given volume amounts. So there's only one gas law that has to do with pressure and volume, and that's Boyle's law. So the first thing you have to do in a conceptual problem like this is understand that we are looking for a factor. How many times larger or smaller the pressure would be given the fact that this volume is changing from 4 to 8. So since we're looking for a factor of how many times, we need to figure out how many times bigger or smaller the volume is. So in this problem, our volume goes from 4 liters to 8 liters. So 4 to 8, that's 2 times bigger, or larger. Okay, so now we know what factor it's changing by. The second thing is to understand the relationship of Boyle's law. Boyle's law is an inversely proportional relationship. Inversely or indirect. So that means that as volume increases, the pressure decreases. They're opposite of each other. So if the volume gets 2 times bigger, like we have up here, 2 times bigger, then that means our pressure has to decrease by the same amount or get smaller. So the pressure is 2 times smaller, or it decreases by 1/2. Okay? In the second problem for Boyle's law, we are dealing with an actual guess method problem where we have to do a full solution. In this one, we have a sample of gas that has a volume of 9,500 milliliters, a pressure of 1.2 atmospheres. It asks us what the pressure is, so there's our question, at a volume of 500 milliliters. Okay, so the first thing you have to understand in this problem is this first sentence here is giving us the initial volume and the initial pressure. And then it tells us what the pressure would be at this new volume. So as far as your givens go, you know that the initial volume, which we label V1, is 9,500 milliliters. And it's important to put that decimal in the 9,500 because that tells you your significant digits. The initial pressure, which we label as P1, is 1.2 atmospheres. Remember, ATM stands for atmospheres. And then we are also given the final volume, which we label as V2, is 500 milliliters. And that one also has a decimal after it. We know that we're looking for the final pressure, which is P2. And we know from our initial pressure that our units are going to be atmospheres. So the equation for Boyle's law is P1 times V1 is equal to P2 times V2. Or the better way to say that is the initial pressure times volume is equal to the final pressure times volume. And then we just substitute in our numbers. So our initial pressure is 1.2 atmospheres. You don't have to write the units if that confuses you. And the initial volume is 9,500 milliliters. Notice I put the decimal in there to keep my significant digits. The final pressure is what we are looking for, so we just write P2 into the equation because that's a variable we're trying to find. And our final volume is 500 milliliters. So to solve this, the first thing we need to do is multiply these two numbers since they are next to each other. So when we multiply 1.2 times 9,500, we get 11,400. And that is equal to our final pressure times 500. Okay, so now at this point, to solve this, we've got pressure times volume here. So to solve for pressure, our final pressure, the opposite operation, if these two are multiplied together, is to divide. So we need to divide both sides by 500. So that cancels out the 500 on the right, and then 11,400 divided by 500 gives us 22.8. Alright, and then the last thing we need to do is look at our significant digits. And so that means we need to look back up at our givens that we wrote down. So it's very important to write down your givens correctly, straight from the problem, so that you have the correct significant digits. So again, remember the decimals on this 9,500, and I also put the decimal when I wrote the givens down. You need to be very careful with that. Alright, so if we look at our givens, 9,500 has 4 significant digits. Our initial pressure has 2 significant digits, and our final volume has 3 significant digits. The 9,500 and the 500 both have zeros in them, but because there's a decimal in the number, those zeros are significant. So remember, trailing zeros, as long as there's a decimal somewhere in the problem, count. So our least significant is 2, which means we also need to take our answer to 2. So that means we're going to keep the first 2 digits. The 8 rounds the 2 up to a 3. So our final answer for our final pressure is 23, and then we need to put our units on there. Atmospheres. And again, remember, we know it's atmospheres because our initial pressure was atmospheres, so it has to be the same units. And that is how you do Boyle's law.